Hi, I'm Kyle Adams, and tonight, we're going to talk about Pydantically perfect in every way. This presentation is going to be a deep dive on into using Pydantic, which is a speedy data modeling and validation library to wrangle ordinary data. Now, first, I want to give you a little bit about me. I'm a software consultant at a company called TestDouble, and we're a software consultancy based in Columbus, Ohio. And we are known for, we have remote workers, even though we're based in Ohio, we have remote workers across the US and Canada. Now, we're known primarily for Ruby and JavaScript, but we actually work across a wide swath of tech stacks, including Python, which is why we're here tonight. So, our story opens as you sit down at your keyboard and to work on your next work ticket. And you take a look at it. Doesn't look too bad. You're going to be pulling in patient data. It's probably going to look something like this. So we've got an ID, first name, then another record with an ID, the first name. Pretty sensible, straightforward, short and sweet. Now let's open the attached example to see what it actually looks like. Well, we've got a problem. We've got Pascal snakes, as I refer to this casing scheme. We've got nested data. We've got a value that is nested within an object that is nested within a list instead of just being directly associated with the ID key. And we've got whatever's happening here, where we've had an ID that's in one place, and in another place, it's called MRN. So we've got some data cats to herd. Fortunately, we have a cat herder, and his name is Pydantic. Now, some of you may be wondering, and so I want to take a moment before we get into the really technical advanced wizardry stuff to give a brief overview of what Pydantic is. And there may be people who are asking, what is this Pydantic library? Well, as I've mentioned, Pydantic is a Python library for data modeling and validation, but let's take a look at a basic example to see that in action. So the first thing that we have is we have to define our model. The first thing we're going to do is define our model. Now I feel like I'm too close. But if there is more feedback from the chat, let me know. So we've defined a name, which is a string, a breed, which can either be a Labrador or a Chihuahua, and an ID, which is an integer. The next thing we do is we load our data, and we're doing that here using model validate. And that's going to both parse your data and validate it. Now, there are actually two ways to load data into a Pydantic model, depending on the context. The first way is with a function. And that's what we've seen already in this example, because this is a good way to load your data in if you don't control your data. For example, if you're getting it from a third-party API. Now, the second way is with a constructor and keyword args. And you see this a lot of times in blog posts about Pydantic or documentation. This is a really good way to use if you control the data. Another good example would be for tests. Once we've loaded our data in, then we can use it to do whatever it is that we want to do for either our, maybe we've got a brilliant money-making idea, but in that case, it's moving healthcare data around. So once we get the data into the model, importantly, we can also get it back out of the model using model dump, and that will serialize it to either a Python dictionary or a JSON string.
And the last thing that I want to highlight is that we're protected. So if we try to pass in bad data, and in this case, I try to pass in a dog whose name is Spot, has a breed of boxer, and an ID of 2, then it's going to throw a validation error. And I want to go through that validation error a little bit because there's some good info in here. So the first thing is it tells me how many validation errors there were. And that's really important when you're dealing with a complex object with a lot of data in it. Our example is pretty simple. It's pretty straightforward to see where the error is at. But when you have large objects, that can be a lot harder thing to track down. Not just where it is, but how many, because you might have multiple validation errors too. So the next thing is it shows me exactly the kind of information that I need to see in order to debug where my validation error is at. It tells me what field is problematic. In this case, it's breed. It tells me what the input should be. In this case, I'm limited to Labrador or Chihuahua. And it tells me what I actually sent in, which was boxer. So that's my error. Now, when we were playing around with Pydantic the first time, as we were learning it, this was kind of a light bulb moment for us. Because we realized in Python, type hints give you build time type enforcement. But with Pydantic, that build time type enforcement now becomes runtime type enforcement. And that was we didn't realize it at the time, but that became a very helpful thing when dealing with APIs that would spew a lot of really messy data, to have that kind of runtime data enforcement, data typing enforcement in place. So now you all have graduated Pydantic 101. Don't expect any diplomas in the mail. So we're going to move on to the more advanced wizardry. Back to our problems. We're going to take them one at a time. We're going to start with Pascal snakes. So Pydantic's solution to this is something called aliases. And Pydantic handle a let's take a look at what we might do if we didn't know about aliases. So we could just mimic the same casing structure in our model. Why would this be bad? Well, we're going to see this. This is going to be a recurring theme tonight. It's allowing the complexity from the data to seep into our code. And so that means any code that interacts with our patient is also going to have to use these kind of non-Pythonic naming conventions, case conventions. Aliases, on the other hand, they let us confine the external complexity to the Pydantic layer. Here, we're using the Pydantic field to define the alias as part of the attributes metadata. These aliases are alternative names available to Pydantic when validating or serializing. The problem with a field level alias is that in our example, we only have 2 fields. It's very easy to do. But when you have 20 different models with 10 to 15 fields each, it gets to be a lot of typing. So it'd be really nice if there were a way to automate all of this typing. Of course, Pydantic has a way to automate all of that, and it's called alias generators. So our second pass here, our third pass, is going to be using an alias generator. Every Pydantic model has a model config attribute in it, and this model config attribute contains kind of the default configuration if you don't touch it at all. But we can override that with the config.dict object, and we can pass in an alias generator. And this alias generator will be used to create aliases for every field in the model. Now, Pydantic also offers a few out-of-the-box alias generators for our convenience, including the toCamel function that we see here, which transforms the names into camel case. However, our actual data isn't in camel case. It's in Pascal snake case. So what are we going to do about that? Well, it turns out we can also create our own alias generators. Alias generators are just functions that take in strings and return other strings. So here we're taking in our snake case field name, and we're converting it to a Pascal snake case field alias. Oops. So once the custom alias generator is ready to go, we can pass it to our into our alias generator. Now, aliases are awesome. We should definitely do more of them. But there are some gotchas to know about them. So Pydantic's default behavior with regards to aliases is inconsistent across validation, which is when you're reading data in, and serialization, which is when you're dumping the data back out again. When we're doing validation, Pydantic prefers the field alias. But when you're doing serialization or writing out, it wants to use the field name. I'm sorry, I'm trying to hold this at just the right place. So the first trap happens when validating, where Pydantic's default is to use the field alias. And that trap is constructing. Remember when we talked about how we could load data into a model with keyword arguments in the constructor? Anyone want to venture a guess as to what's going to happen here, where we have our toPascal snake alias generator, and we're trying to construct a patient using snake case in the constructor? If you guess validation error, pat yourself on the back, and let's take a look at what's going on here. So we have our input is snake case, but Pydantic is expecting Pascal snake case. So it's saying, hey, first name is required, and you didn't give it to me. We gave it to them, we just used the wrong case for it. So how do we fix this? We can switch the validation behavior to use field names by default rather than the aliases by setting the validate by name in the model config. The trade-off is that anytime we want to validate by alias, we have to now explicitly set it using that by alias setting. So as you can see, we'll need to, anytime that we want to do a model validate, we now need to explicitly set by alias. So there's another way, and that's that we can say, okay, we want to validate by name or by alias, by saying those both to true. And the trade-off here is that this is a great option if you don't mind your validation being a little bit less strict. And what Pydantic does is it's checking both the names and the aliases to see if they exist and if they are set to a valid value. If they do and they're set to a valid value, it'll use that value. Now, bit of foreshadowing here, but I want to remind you that when serializing, Pydantic uses the field name. The second trap is when we try to take the data in our model and serialize it back to another format, like a Python dictionary or a JSON string. Here's what that behavior looks like in the code. Now, using a different case scheme when dumping out could be a problem if we have downstream systems that still expect it to be in Pascal snake case. We need to override Pydantic's default behavior when doing that model dump. We can do that by setting a by alias argument. We can do that at the function level, or as we've seen previously, we can set it at the model level by setting this serialize by alias to true. So now we can safely serialize and get the results that we want with the Pascal snake case in the output and avoid that gotcha. Now, for our next spell, we're going to look at nested data. So what do we do when the data that we want isn't at the level in the data structure that we would like it at? Pydantic's solution should look familiar, as alias paths are adjacent to aliases. As with our Pascal snakes issue, first pass might be to represent the nested values. So here we have Jim nested inside of value, nested inside of list, nested inside of first name as nested models. So here now we're nesting our name inside of a value model, which gets nested inside of a list, which gets nested inside first name, which gets nested inside of patient. Now, I will admit, there's a certain amount of simplicity to this approach. But let's look at what happens when we try to access our patient's first name. Yuck. We have, did I lose? Okay, sorry. We have this long value where we, instead of just being patient first name, it's patient first name, index 0, dot value. So alias paths let us dig into our data structure and pluck out just the values that we want. Let's take a closer look at how that works. We define a path that navigates from the root of the object down to the data that we want. In this case, we need to go down to the first name field, then to index 0 in our list, and then into the value field. Once we have our path, we can pass that path into the alias path constructor. 2 notes here. For this example, I've defined the path and the alias path separately so that I could fit them onto one slide. But in real world code, you'd almost always just define the path inline. For my second note, some of you may be wondering why we're using validation alias here rather than alias. Unfortunately, as you get deeper into more advanced alias features, you lose the ability to be bidirectional. What I mean by bidirectional is that when you read data in, it does the same things as when you write data out. So in this case, we can no longer serialize our first name field back out to a nested path. So if I do this model dump, it's just going to put it in first name Jim. Consequently, that's why we're using validation alias here. It's because alias path only works on input and it doesn't apply to, which is validation, and it doesn't apply to output, which is serialization. So back to our updated code. How does it look to access a first name now that we're using alias path? Much better. Now it's just the patient.firstname that we expected. All right, we are at our final incantation here, and this one is going to deal with the discrepancy between ID in our first patient and MRN in our second patient. And I will say MRN here is a medical record number. It's a common identifier in healthcare systems. So that's what MRN is. And it's time to solve the problem of multiple paths to the data that we want. How do we tell Pydantic about these multiple paths? Well, we're going to use alias choices, often in conjunction with alias path. We could try to deal with the problem by creating 2 different models. The first model would deal with the ID that's deeply nested. And the second would handle our MRN model. The problem here is the same as with our other examples. We're letting the complexity of the data structure seep into our code. And so now every bit of code that deals with the patient has to know, does this patient have an MRN? Am I checking the MRN for the ID? Or does it have a deeply nested ID? So instead, let's write a single model and let alias choices abstract away that complexity. Here we can see that alias choices lets us specify multiple paths at which we might find the user's ID. In this case, either under an MRN attribute or following an alias path to a more deeply nested number. And again, I've split alias choices onto its own line for brevity's sake. However, you'd likely inline it into that field definition in the real code. So now we've talked about how to address all of our problems. We can kick back and relax, right? Well, what does a full solution look like though? So let's step through this. We have all of our imports and we have a few utility functions here. We've already talked about to Pascal case. So I just want to point out this genPath function. We have a pattern with our alias paths that you may have noticed. Specifically, we navigate a list and then we get the value from the first item in that list for each of our attributes in our model. And genPath helps dry up that pattern a little bit. So looking at the model, in our model config, we use toPascal snake to deal with making sure that we can use nice Pythonic attribute names. And we use alias path as generated by our genPath function to give us access to the deeply nested data. And then finally, we use alias choices to normalize across multiple paths access to the user's ID. Now we're back to our problematic data here. Let's see how it does when we run it through our new Pydantic model. Perfect. This is exactly what we want. We've abstracted away the complexity of the third-party API, the third-party data schema, and now our client code doesn't have to know anything about that. It just asks for the patient ID, gets the ID. Asks for the first name, gets the first name. So we've hit the portion of my talk here where I'm going to open up for questions. And while we're talking, I'm going to throw my contact info up there. If there are any questions that you guys have that we don't get to talk about, feel free to reach out to me on LinkedIn or email me. I'd love to set up a Zoom call. This is the kind of stuff that I love to talk about. So any questions?
Yeah, actually, here, I'll give you this mic and you can ask us so everyone can hear it.
Have you created any Pydantic models for OWL files?
For what kind of files?
OWL files? OWL? They're
I have not.
okay. They're a transfer mechanism for medical terminology records from one system to another.
Yeah,
That seemed relevant.
that's interesting because I have not created Pydantic models for OWL files, but I've created lots of Pydantic models for Fire, for HL7 Fire stuff. And that's another data transfer schema that's common in the healthcare world. And I will say modeling Fire in pretty much anything is a lot of work. Fire is a very big specification if you've ever dug into it.
All right, more questions? Well, you all got more questions. What have there been downsides to the static typing Pydantic? Has it caused you to spend more time someplace, or has it always been a total upside?
Yeah, I think probably the most difficult thing is the learning curve. It's the human aspect of it. And honestly, it's less to do with Pydantic and more to do with like runtime enforcement of typing. Like that's kind of a shift if you've spent a big portion of your career working in a very, I don't want to say Python's loosely typed because it's very complicated. It's strictly typed, but it's dynamically typed, and that's a whole other conversation. But yeah, it is. Most people come into using Pydantic with a mindset that it's a bit of a shift, and it can be a bit jarring to see all these red squigglies show up in your code that weren't there before.
Other questions for Kyle?
I will also say, sorry, to build on that a little bit more, this talk actually comes out of a series of exercises that we created when we were rolling Pydantic out at the healthcare organization that I was working at. So this actually came out of that challenge of getting people up to speed on Pydantic.
How many people in the room are using statically typed and Pydantic? Oh, so lots of people still to adopt. All right, good question?
My question is like, I use different integration products like MuleSoft, Dell Movie, and stuff like that.
Mhm.
Like, if I have to deal with the data which comes from different source systems, like you have all kinds of crazy data coming, but we want a kind of a single schema.
Yeah.
Like, if I have to use this library, like, am I running it in like a Lambda, like how would I use this library, Python library, on top of what my integration platform is to kind of validate the data, maybe, unify it
Yeah.
and put it somewhere else, like in a CSV or JSON.
So what we did is to say, okay, we want to keep the mess as close to the boundaries of our systems as possible. And then this particular engagement, it was a collection of microservices that were all talking with each other. So we wanted to keep, when messy data came in from all the different platforms that we were integrating with, we wanted to clean up that data as soon as possible, like right at that boundary. And we used Pydantic to define a whole set of models that then we packaged up, and it became like a schema that could be used across multiple applications. You could just, in every application, every microservice that you spun up, you could download this one library and would define all of the essentially domain models for the whole system. So patients, facilities, doctors, all of those domain models were defined in this library, and they were all defined in Pydantic. And so then that gave us a tool for any microservice, any integration that did, it could clean up that data, put it into our internal schema, our internal domain models, and then our internal systems kind of all work seamlessly because they all had the same view. They all knew what a doctor was. They all knew what an employee was. They all knew what all these domain models were. So does that answer your question? Yeah.
Any other questions? Are
So Python for a bit now, for the last couple of years, is bringing in typing into the language, and we're seeing it more and more feature rich in that area with 13 and 14
Yeah.
now rolling out. Are you think Pydantic's significance will devolve now with the typing that's coming into Python itself?
Yeah, so I would say Pydantic is actually built to take really good advantage of all of that new stuff. And that goes back to those yellow slides where I talked about the light bulb moment, and that all of these new things that are being added by Python are all build time things. Like you have to run MyPy or Pywrite to do static analysis on your code and flag anything that might be a problem. If you run it without doing that static analysis in production, Python's not going to complain if you store an integer in a variable with a string type on it. And so what Pydantic does is it kind of fills in that gap of Python's defining all of these build time type hints and features around those. Pydantic is taking those over and enforcing them at runtime.
There's still no performance improvements because you're using typing in your code, like compiled
Correct.
languages, like
Yeah, it is. There's no performance improvements. What we did find, and there are lots of great talks online about this, we found it reduced the number of bugs that we could run into. And one of the analogies I've seen that I love for this, unit testing and various types of testing, if you think about your bugs, it's like a big circle, like a Venn diagram. Unit tests punch holes in that big circle of all possible bugs. So it looks like a little bit like Swiss cheese. But when you have types that are enforced at runtime, that like slices a whole slice out of that realm of that circle of all the possible bugs, so that you don't even have to worry about these kinds of problems.
yeah, whole classes of issues just go away.
Yeah, yep. Now there are other issues. I don't want to. I'm not here to be a, a strong typing evangelist, but we did find that in our real world use.
Excellent. Any other questions for Kyle?
Do they have a competitor for this thing?
Can you repeat the question?
Yeah, go ahead.
Is there a competitor, like someone who's in the same space?
Oh, like a competitor? Is there a competitor to Python?
Yeah, is there a open source library that does similar things to Python? There is. I think it's called Marshmallow, and so we had initially built our microservices on Flask, and specifically using a library for Flask called Flask RESTX that gave like REST API capabilities to Flask. Flask RESTX is currently rewriting because they had a lot of these capabilities baked in. They realized they weren't able to keep up with the rate of innovation. They were rewriting to specifically to support Marshmallow, but also with kind of second-class support for Pydantic. Now, I'm not sure if they're maybe rethinking those plans because that was way back when Marshmallow and Pydantic were both getting started, and Pydantic's kind of come out on top. But yeah, there are other libraries out there that do this. They're just not, they don't have the community that Pydantic has.
Awesome. If there's any other questions, I think we're good. Let's give a big round of applause for Kyle.
Oh,
One more thing here.
one more thing here. I want to leave you guys, if you leave here with only one thing in your head, I want that to be Pydantic's aliases are useful and I should read through the docs. Or we can simplify that to aliases are useful. Now,
Still read the docs.
I will also say this is not the end. I mentioned that this came out of a series of exercises we did, and we actually turned them into a series of blog posts. So I tell everyone, I don't expect you to remember anything that I said here tonight. But what I do hope you remember is if you forget, that you remember that our blog is at testdouble.com/insights, and you can go read this Pydantically Perfect blog series to find the stuff I covered tonight is in the first 3 blog posts. We actually have 6 more that are in the works right now. So there's going to be a lot of information on kind of advanced Pydantic details out there. So when you're dealing with gnarly data, come back to the Testable blog and figure out if we've got anything in there that might help you.
Excellent. Super awesome.
All right.
Thanks
Thank
again.
you very much.
Give a big round of applause, Kyle.